Okay, here's a quick review for our Parent Graphs Essential skill. If you take a look at the slide, I went through and identified all 8 of them. You'll notice the similarity of the A, the H, and the K follows through on almost every single one of them. And then I went through and I color-coded. So the orange in each one of these is the thing that makes the equation what it is. I'm going to go through and talk about the transformations. So if we have an A value that is negative, we know that that's a vertical reflection. And then when we talk about vertical stretch and compress, you ignore the sign on the A. That's why I have the absolute value bars down there. So then we also have the shift right-left business. So again, stuff that we've already done in class. We just want to go through a review, do a couple problems here. Okay, so our very first one, we have a parabola. Now, I know that it's going to be a parabola based off of the exponent. So I look at this exponent. I still see my A, my H, and my K, but that exponent of 2 tells me that I'm dealing with a parabola. So I can go ahead and identify what this thing is called. So let's write down parabola. I also realize I have parabola written up at the top, but that isn't going to be the case on the test. So I want to make sure that you can recognize these. Okay, the first thing that I personally like to do is identify the H and the K. So the H value is going to be inside the parentheses with the X, and then my K value is going to be, in this case, added at the end. So I know that my locator point for this is going to be +3, +1. As soon as I identify my locator point for parabolas, I immediately start my transformations. So this is +3, so I'm going right 3. And then +1, I'm going up 1. Okay, now I'm going to go back to this and I'm going to take a look at the A value. So my A is going to be 2. It's not negative, so I don't have a vertical reflection. And 2 itself is larger than 1, which means this is going to be a vertical stretch. And then I do have to specify by how much. So vertical stretch by, and then use the A value. So we're going to go ahead and put a 2 there for this. All right, let's go ahead and graph this thing. So I'm going to go ahead and plot 3, 1. So 3, 1 on my graph. And then you can make a table to find additional points, but you don't have to. If we go right 1 from HK, then we can use the A value to help us. So in purple, and this is not something I would normally do on my graph. This is just to show what I'm thinking. I'm going to go right 1 from HK. And then I'm going to take a look at the A value, which was 2. It's positive, so I'm going up, and I'm going to go up 2 units. As soon as I go right 1 up 2, I'm going to go ahead and plot that point. That's my next point on the parabola. And then we know that parabolas have symmetry. So if you went right 1 up 2, you can go back to HK and go left 1 up 2 to find its partner point. Again, the purple isn't necessary. It's just so you can see what I'm talking about. And then parabolas have nice smooth curves. So I'm going to start at the top. I'm going to dip down, make sure it's not too sharp or pointy. And then make sure that on the edges here. So I'm just going to take a look at this guy. On the edge over here on your parabola, you want to make sure it doesn't go straight up and down. So don't follow the graph paper on this. If you do, it's no longer a function because it wouldn't pass the vertical line test. So make sure that it kind of arcs and curves out like it's supposed to. Okay. Now, let's take a look at the next one. And then we're done with that one. Now, you might be asked what the domain is. Well, we know that the domain on a parabola is all real numbers. You might be asked what the range is. Well, you can take a look at the graph and see that the lowest value for the range is the y value of the vertex, and then it keeps going on forever. Is it a function? Yes, it passes the vertical line test. Okay, let's take a look at the next one. So, if I take a look at the equation, see the exponent is a squared, which means, again, this is a parabola. So, parabola. Then I'm going to go ahead and pull out the H and the K. So the H and then the K. Remember, it's opposite of the inside, so -2, and then exactly what you see on the outside, -1. Okay, I'm going to start my transformations. -2 tells me left 2. -1 tells me down 1. Okay, now I'm going to go back and I'm going to take a look at the A value here. Okay, that A value has a negative sign. That means that this is vertically reflected. So I have a vertical reflection. Or you can also say, depending on your teacher, that it is reflected over the x-axis. I'm a big fan of vertical reflection personally. Okay, so that takes care of the negative on the half. Now we have the half itself. So just half itself. Half is smaller than 1, which means that this is a vertical compress. So a vertical compress or a vertical compression, but you have to say by how much. This is by a half. All right, let's see, -2, -1. Oh, good, I didn't run into my graph. Okay, so I'm going to plot -2, -1. I'm going to do that purple thing again, so I'm going to go right 1. Then from there, I'm going to go down because my a value is negative, and I'm going to go down a half. So you don't split the fraction up. It's just down a half, and then plot the point. Use symmetry on the other side, and plot its partner point. Go ahead and give it a quick sketch. And it should look wider than your other one. Notice I made sure that on the edges, I don't have my parabola going straight up and down. So it's kind of curving out. Okay, let's take a look at the next one. Okay, I'm going to do the exact same thing. I'm just going to take a look at, well, I see the a, the h, and the k, and I'm going to look at the exponent. That exponent is a power of 3, which is a cubed, which means this is a cube. So I write down cubic. H and k, you do the exact same thing. Opposite, exact. So +1, -2. All right, so this is going to be right 1, down 2. Take a look at my a value. So I look at my a value there. It's not negative, so there's no vertical reflection, but it is a fraction. So let's see. Is half bigger or smaller than 1? Well, smaller than 1. So even if you have a fraction, that doesn't necessarily mean it's a vertical compress. You have to compare it to 1. So 1/2 is definitely smaller than 1, which makes this a vertical compress. Yes, you have to specify vertical. It's required. By, and then you state the a value. Now, if the a value is negative, we don't use the negative when we're talking about that. It's just the number itself, so like the absolute value of it. All right, let's graph this thing. So this is going to be 1, -2. Okay, I'm going to take out my purple pen again, so I want you to see what I'm thinking. So the whole right 1 business still works for cubics. So from my HK, I'm going to go right 1. I'm going to take a look at my a value, so what I highlighted in yellow. It's positive, so I'm going up. Don't split the fraction up, just go up a half. So I'm going to go up a half. I'm going to plot that point. Now, cubics have symmetry also, but they don't have the same symmetry that parabolas do. So parabolas have like a right-left symmetry. These have a diagonal symmetry. So if I went right and up, I'm going to go back to HK. I'm going to go left and down. It kind of looks like a straight line in the middle of a cubic. It's not, but it kind of looks like one. So one of the tricks that I use when I'm graphing my cubics, just to make sure that little twist actually happens at HK. If you put your pencil on HK itself and you go to the very first point that you plotted and you go half of a parabola up, that takes care of the right side. Now go back to HK and go half of a parabola down. Now you can see that right in the middle there, it actually looks like that little twist happens right at HK. That's important. So try to do the start at HK, half a parabola up, start at HK, half a parabola down. Okay, for the next cubic, and I want to continue doing it kind of this way, is I'm going to do the first one, and then my recommendation to you is to pause the video, see if you can go through and do the entire second one that's on the slide, and then unpause the video and come back and check and see if you did it correctly. So pause now, give it a shot. Okay, let's see how you did. So I went through and I identified that the exponent was a 3, so I know it's a cubic, which I colored in orange. Then I went to the locator point. So I highlighted the h value of the locator point in blue, but remember it's opposite, so it's going to be -2 instead of +2. Then I highlighted the k value in purple, which is exactly what I think it's going to be. It looks like a +1. It is a +1. I immediately identified left 2, up 1 from that point, and then I went back and I took a look at the a value, which I highlighted in yellow. That is a negative number, so I know there's a vertical reflection. that was the first thing I identified from the A, and then I looked at the number itself. So I ignored the sign of the absolute value of it, so just the 3. That 3 is larger than 1, which means I'm going to have a vertical stretch by that number, which is 3. And then I went through and I graphed it. So I plotted -2, 1, and then I kept with the purple so you could see what I was doing. I went right 1, and then it was negative. So I went down and I counted 3 boxes. So I went down 3 boxes and then I plotted the point. Then I went back to HK and I went left, so from HK. And then I went up 3 boxes and plotted. It's still the same thing. Half a parabola on one side, half a parabola on the other side. You should see that the twist looks like it's happening right around HK itself. Okay, so now we have the same idea here. So if I take a look at this, I am trying to determine that this guy doesn't have an exponent this time. So I'm looking for the behavior around the x itself. So if I highlight in orange, you can see those bars. Those bars are telling me that this is an absolute value function. And so I'm going to say absolute value. How we go through and identify stuff is the exact same thing. So I'm going to take a look at the H, and I'm going to take a look at the K. Remember, it's opposite H, so 1, exact K, -2. So that tells me write 1 down 2. I'll take a look at my A value, which I highlighted in yellow. Okay, not negative, so there's no vertical reflection. 2/3. 2/3 is smaller than 1. That means that this is a vertical compress or vertical compression. And then you do have to say by how much, and that's vertical compressed by 2/3. Okay, now absolute values are special. The definition of an absolute value actually is a portion of a line pointing right and then a portion of a line pointing left. So you can use a ruler. These are like pointy and kind of sharp. They look like V's. And because of that, A can actually be treated like slope. Now, you can still do the right 1 business. That still works. But since these are lines, you can technically use the 2/3 A value as slope itself. And I'll show you that it still works. So if we go through and we plot 1, -2. Well, let's say I do slope. So from here, my slope is positive, so I would go up to right 3. So if I go up to right 3. So I'm going to put the purple in there just so you can see what I'm doing. 2, right 3, and plot the point. Now, let's go the other way too. These guys also have symmetry, kind of like parabolas. It's this right-left symmetry. So up 2, left 3. Okay, so now let's go through and actually graph this thing. Let's see if I can get a straight line out of this. So if I start there, there's that side. Start there. There's that side. And then we do have arrows on the end of this. Okay, so I did say the whole right 1 works. It's true. It does. Let's take a look. So let's say you want to stick with the whole right 1 business. Not a problem. If we go back to HK and you go right 1, that distance up to get to that point is 2/3. So you don't separate the 2 and the 3 if you're going to do it this way. You just do right 1, up 2/3. If you take a look on the other side, left 1, up 2/3. It's like all of the purple that I'm putting on here is not part of the graph. It's just the motions of what I'm doing to try to get the points. Okay, that's it for this one. Okay, go ahead and pause. See if you can do the next one. Come back and check your work. Okay, go ahead and check your work. It's definitely an absolute value. Highlighted the absolute value bars in orange. The locator point, it's the exact same thing I've been doing the whole time. So highlighted in blue the H value, highlighted in purple the K value. Remember, it's opposite H, exact K. And then I immediately started doing the transformations. So left 3, up 2. Then I took a look at the A value. It's negative, so that's a vertical reflection. And then I look at the absolute value of the A value, so just 3. And I compare that to 1. Bigger, it's a vertical stretch. Smaller, it's a vertical compress. It's bigger. And then I went through and I actually used slope here. But you get the exact same thing if you do the right 1. Like, they're identical to each other. Okay, let's keep going. Okay, exponential. Okay, this does not follow some of the other rules. So first thing I'm going to look at, I see that the x is in the exponent. Whatever it's in the exponent of, that helps you identify what the parent is. So this is telling me that this is exponential because the x is in the exponent of a number. In this case, that number is 2. That 2 that I just highlighted has nothing to do with the transformations at all. It is just the identification of what this thing actually is, whether it's a cubic or a squared or a hyperbola. This guy's an exponential. Okay, my locator point, I'm going to do the exact same thing. So opposite for the h and exact for the k. So this is going to be -3, -1. Okay, now I'm not going to write locator point here, folks, because it is not the locator point. I'm going to do a little bit of work off to the side. I'm just going to identify it as hk. And I'm actually going to hold on to locator point on this until the very end. Now, I'm going to use hk to describe this thing. So let's use that hk, left 3, down 1. Okay, I'm going to go back. I'm going to find my a value, highlighted in yellow the whole time. It's whatever's being multiplied in front of the 2. So right there, that I just highlighted in yellow. Well, there's nothing there. The only thing you can actually multiply by that does not have to be written down is 1. So when you have situations like this, consider putting in a times 1. It's a little bit easier to determine, okay, what is this thing actually doing? Okay, so if I take a look at my a value of 1, it's not negative, so it's not a vertical reflection, and how it compares to 1, it's exactly 1. So this doesn't have a vertical stretch or compress itself at all. So my transformation explanation is completely finished. Okay, let's graph this thing. So I'm going to go to -3, -1. And -3, -1 is not a point on the actual curves. I just put a little mark there. It's kind of like my reference point. That is where your horizontal asymptote goes through. Every single exponential function is going to have a horizontal asymptote, and it always goes through hk, this whole year for us. Okay, so how do we find the locator point? All right, well, you do it fairly similar, to how we found points before, where previously we did right 1, and then you used a. Okay, the big difference between those and this guy is there's no right 1. You immediately do a. So I am going to hover my pencil on top of hk. So I'm not touching hk, I'm just hovering over it. My a value is positive, so I'm going up, and it is 1 unit. So I'm going to go straight up 1 unit from hk. Again, the stuff that I write in purple on here isn't necessarily anything you have to write on your test. This is just so you know that's where I'm landing. That point where you just landed, that is the locator point. So it's the whole after you used a. Well, if you take a look at this location, this point, and now I can put down as my locator, is -3, 0. It is 1 higher, because my a is 1 higher than my hk was. Now, for us, this whole year, exponentials are going to hug the asymptote on the left-hand side, and then it's going to curl away from the asymptote. So we're going to hug on the left, curl, and then run away from the asymptote. Just like when I did my parabolas earlier, and actually all of the other ones, I made sure that I didn't actually go straight up, because then it's not a function anymore. This guy's a function, so make sure it's still curled. Okay, why don't you see if you can do the next one? Remember, identify hk, use hk to describe. hk is not the locator point. So go ahead and check yours against mine so far. So I identified it as exponential. It is the thing that I highlighted in orange. That 2 is the base of the exponent. That makes it exponential, and that orange 2 is the parent. Has nothing to do with the transformations. I identified hk, so h was the opposite of what I highlighted in blue, and then purple for the k. And I immediately went, okay, off to the side, my hk is 1, 3. Then I said, okay, right, 1 up 3. So I'm going to start there for my graph. Then I just highlighted my a value in yellow, and yeah, there is something this time. It's negative, so it's a vertical reflection, and it is 2. Well, 2 itself is larger than 1, so it's a vertical stretch. And I know this one's different, so I wanted to stop a little bit before I got to this. Okay, so I'm going to go 1, 3, and I'm going to mark it on the graph. Immediately put your horizontal asymptote through that. So that's where your horizontal asymptote is located. Okay, I'm going to grab my purple pen so you can see what I'm thinking. From HK, so I've got my pencil hovering on HK. My A value, I'm going to do it immediately. Well, it's negative, so I'm going down. And it is -2, so I'm going to go down 2 boxes. Plot that point. That's your locator. So our locator, we can already identify right now, is 1, 1. So back up in my locator point, 1, 1. Okay, now I said previously, and this is true the whole time we are together this year, you're going to hug on the left, and then it runs away from the horizontal asymptote on the right. So hug on the left, curl, run away from the horizontal asymptote on the right. So there's our sketch. Okay. Moving on to the next one. So we'll pick up a little bit more speed here. I wanted to slow down for the exponential because it doesn't really follow the other rules. All right, we'll take a look at this. Let's go ahead and highlight what makes this thing what it is. Well, it's the fraction bar right there. Notice that the x is in the bottom of the fraction. If the x is in the bottom of the fraction, this thing is a hyperbola. You can also call this a rational function. Those are the same things. So for us this year. So rational functions and hyperbolas, they're the same. Okay, locator point. We can find them in the exact same location as before. So it looks like it's going to be -2, -4. And go ahead and identify what's happening so far. So that's left 2, down 4. Now the A value for this guy can either be on top of the fraction like the 3 is, or it can be out in front of the fraction. So like 3 times and then 1 over x plus 2. So it's going to be a tiny bit tricky because your A can be on top of the fraction or multiplied out in front. They're both technically the same thing. Okay, so that 3 is not negative, so it's not a vertical reflection, but it is larger than 1. So I have a vertical stretch, and it is by, so I do the exact same thing the whole time. Go through with my explanations. Okay, so let's go to -2, -4. So when I go to -2, -4, where my HK is located, I'm going to mark that location. Because for a hyperbola, that is where your 2 asymptotes intersect. That's where you have your horizontal asymptote. So let's put our dashed lines through. Yes, you have to make sure that your asymptotes are identified on the graph. And then -2 as well. So this one's got both. This is the only one you and I are going to do that actually has a vertical and a horizontal. Okay, so now I'm going to grab out my purple pen so you can see what I'm thinking. I'm going to start at my HK. I can do the right one again. It's kind of magical. So I'm going to go right 1 from my HK, and I'm going to do my A value. My A value is positive, so I'm going up, and it is 3. So I'm going to go up 3 boxes, and I'm going to plot that point. Now, the symmetry for a hyperbola is very similar to the symmetry for a cubic. Like it looks like a line in the middle. It's not, but it kind of looks like one. So I'm going to go back to HK. I'm going to go left 1, and I'm going to go down 3. 1, 2, 3. And I'm going to plot that point. Well, remember, the purple you don't have to actually include. Okay, now by nature of graphs with asymptotes, what they do is they race to the asymptote and they try to like glide right alongside it. So they hug it. So if I'm up in the top right corner here, I'm going to see if I can kind of hug the vertical asymptote, curl. And then after I curl, I'm going to try to get to the horizontal asymptote. Make sure you don't actually cross the asymptotes. That's not something that we do this year. Okay, we're going to do the exact same thing. So we're going to hug the vertical asymptote, curl, and then hug the horizontal asymptote. So there's our graph for this guy. Okay, let's do the same thing. Let's pause it, see if you can do the next one, come back and check. Okay, take a quick check and see if we match. And again, I know I keep saying it, but I don't want you to think that you have to actually draw in the purple things on the test. It might actually confuse you. So this is just so we can see what's happening. But I keep doing that whole right 1 business. Okay, let's take a look at the square root. Okay, square root, same idea. I go through and I take a look at the symbol that I highlighted in orange. That's going to tell me what this thing is. And this is a square root. I can identify the h and the k. Hopefully you're picking up on the similarities here. A lot of them are exactly, well, not exactly the same. They have a very common thread that runs through. Okay, so we're going to say left 1, down 3. I'm going to take a look at my a value. It is negative, so it is a vertical reflection. And then I just look at the number, ignore the sign. It's a half, that's smaller than 1, so this is a vertical compress. By, and the value is a half. Make sure you don't use the negative sign when you're talking about compressed stretch. Doesn't really make any sense. Okay, so let's go ahead and plot our locator, -1, -3. So -1, -3. The whole right one still works. So if you do right one, use your a value. Your a value is negative, so I'm going to go down. I'm going to go down a half. So don't split the 1 and the 2. Just use the -half. This guy does not have symmetry. What this looks like is it looks like a non-function parabola, but it's cut in half. So the negative tells you that you're only getting the bottom half of it. So starting from HK, you have the bottom half of a non-function parabola. You don't have both of them. That would have a plus or minus in front. That's it. Okay. See if you can do the next one. Okay, check yours against mine. So we've got our locator point of 2, 1, so it's right 2 up 1. And then I have a vertical stretch of 3. So from my HK, I went right 1. And then I counted up 3 boxes. Because this is a square root function, again, it's half of a non-function parabola. It's the top half because the a value is positive here. Okay, taking a look at the circle. I wanted to do a couple of things here. I want to make sure that we know how to write it in graphing form, so we'll do a little bit of completing the square, and then be able to identify the locator point, say what the radius is, and then be able to give it a decent sketch. Okay, so the first thing that I'm recommending that you do is kind of shuffle this around. I want my x squared and my x next to each other, so I'm going to rewrite this as x squared plus 2x. They're on the same side of the equal sign. It's not like I'm moving things from one side to the other, just doing a quick shuffle. And then plus, I want to put my y squared and my y next to each other. And then I also want to move my constant. So if it's a -4, I have to +4 to get it to the other side. Okay, here's what we're going to do. We're going to try to complete the square on this. So if I draw out my squares here, here's what I have. I have an x squared. It needs to be a square, so you're going to have to split your 2x perfectly in half. When you split your 2x perfectly in half, then we know the number that completes the square there is going to be 1. So I'm going to add 1 to my x squared plus 2x. But I have to add 1 to the other side at the same time. I got to keep it balanced the whole time I'm going through this. Okay, now let's take a look at the y's. So I'm going to take a box, draw this out. Put my y squared in, split the -4y in half perfectly, so I have -2y, and then to complete the square, that's going to be a +4. So I'm going to put a +4, and whatever you do to one side, you got to do to the other side. Okay. So if you take a look, we have our x squared plus 2x plus 1. That's everything inside the boxes here. What we're trying to do is we're trying to go from the inside of the boxes to the outside of the boxes. So let's see if we can get to the outside of the boxes now. So if I factor, I'm going to get an x plus 1 and an x plus 1, which they have to be exactly the same base and height because this thing is a square. So x plus 1 times x plus 1, I can rewrite as x plus 1 squared. Okay, that takes care of my x's. Drop my plus sign straight down. So if we go back up here, let's see this plus sign right there. I'm just going to drop it straight down. So plus. And we're going to do the same thing with the y's. So if I factor, Look at y minus 2. This better be y minus 2, which it is. If it's not the same, that means you built a rectangle. But we don't want to build a rectangle. We want to build a square. You got to make sure that the base and the height are the same. So I'm going to have y minus 2 times y minus 2, which I know I can rewrite as y minus 2 squared. I'm going to drag my equal sign straight down, and then I'm going to combine the numbers on the other side. So I have 4 plus 1 plus 4. That's going to give me 9. Okay, here we go. Locator point. Using the exact same coloring I've done before. So my locator point here is going to be, and then for a circle, this is the only one where it's opposite opposite. So it's opposite the plus 1, so that's minus 1. It's opposite the minus 2, that's positive 2. I'm going to immediately say what my transformations are. So very similar to what I've done so far. This tells me left 1 and up 2. The only other thing, we don't talk about a circle being stretched. We don't do that. We just talk about the radius of the circle. So we know that the radius, well, it is not 9. It is the square root of 9. You're always going to give a positive value for the radius because it is a distance or a length, and we don't know what it means to have a negative distance or length. Okay, so let's go ahead and start graphing this thing. All right, so I need to be at negative 1, 2, so that's going to put me in the second quadrant, and I need to be able to go 3 in each direction. So I need it to be not huge, just make sure that I got enough space. So let's see. On my x-axis, negative 1, 2, so I'm going to have second quadrant. Label my x and y axes. I only label them in these types of problems because if you've got like asymptotes flying around, it's kind of hard to figure out where your x and y axis was originally. So let's get into a good habit of this. All right, so negative 1, 2. Negative 1, 2. Negative 1, 2 is the center of this thing. It's not an actual point on this guy, so I am not going to plot it. Then I'm going to take out my purple pen that I've been using, kind of explaining what I'm trying to do here. Okay, starting from HK. I'm going to use my graph paper. My graph paper, if I count right, left, up, down, I can find the edges of the circle. Okay, so from the center, I'm going to go 3 to the right. I'm going to plot a point. Then I'm going to go 3 up. Plot a point. Then I'm going to go 3 left. All from HK. Plot a point. Then I'm going to go 3 down. Plot a point. All of those points that you just got, connect them, so try to make it look like a circle. So your HK for your circle is actually your center here. Okay, I think we are close to done. Nonfunction parabola. All right, nonfunction parabola, this can be written a couple of different ways. So I gave you this fashion. I'm a big fan of this one. This is the form that I like. The thing that makes it what it is the plus minus and the square root symbol. That tells me that this thing is going to be, so if I named this, I would say that this is a non-function parabola. Which still looks like a parabola, it just opens sideways instead of up and down. Okay, my locator point. My locator point is still going to be my HK. And this is why I like this form so much better personally. It's still set up the same way. You have A, then X minus H, and then K. You just pull it right out of the form. So this is going to give me 4, comma, negative 1. All right, I can start describing my transformations. All right, so the 4 is right 4. The minus 1 is down 1. Okay, take a look back. Let's see if we have an A value. Oh, we do. It's the number in between the plus minus and the square root symbol. So this is going to be vertical stretch by 2. Now, with non-function parabolas, there is no vertical reflection at all. You'll never say vertical reflection for this guy, ever. Because you have both the positive and the negative, that means you get the top and the bottom. It's one single graph. It's not reflected at all. Okay, let's go ahead and graph this thing. So I'll set up my axes. Then I want to show you how to go from this form to the other form. So I'm at 4, -1. All right, so I need to be on the right. So 4, -1. So I'm going to plot 4, -1. You know that whole right one business we've been doing? It still works. So if I go right 1, my A value, because it's +2, I'm going to go up 2, but it's also -2, so I'm going to go down 2. So from here, I'm going to go up 2 to get the next point, but I'm also going to go down 2 to get the next point. And it is a parabola. Let me label these guys. So there's the top half. There's the bottom half. So we have a non-function parabola. Okay, next thing, let's go ahead and copy this guy over. So if I copy this over, let's see if we can move this over here. So I want to take a look and see how I can start algebraically manipulating this thing. The cool thing about this is the algebraic manipulation is the exact same thing every single time, which is magical. So I'm trying to get to the x, like my job, so I'm going to put a red mark on this. That x is what I'm trying to get by itself. To do that, the very first thing I'm going to do is add 1. So I have y plus 1 is equal to ±2 square root. There's that x I'm trying to get to, minus 4. The next thing I'm going to do is I'm going to divide by my a value, which is 2. So I'm going to divide by 2, cancels that guy out. I'm not going to actually do any math over here. I'm just going to start sliding things over. So I have ± square root. There's that red x I'm trying to get to, minus 4. Next thing, I'm going to square both sides. So I'm trying to get rid of the square root symbol. But something nice happens here also. So left-hand side, I've got y plus 1 over 2 squared is equal to, okay. If I take this squared and I square the plus or minus, well, a positive squared is positive. A negative squared is also positive. So that cancels that guy out. If I square the square root symbol, that guy goes away and that guy goes away. So now the x is free, but I still have the minus 4 with it. Okay, last thing, add the 4. Notice that the plus 4 happens after everything else does, so it actually just gets tacked on the end. So I have y plus 1 squared, or excuse me, y plus 1 over 2 squared plus 4 is equal to, and this is equal to x. These are the exact same thing. They're identical to each other. Now let's see if we can color code our business here. So if you take a look back at the original, I color coded the a value in yellow. Well, that's where it is. It's now in the bottom. I color coded the h value in blue. Well, it's now hanging out on the outside. I color coded the k value in purple. It's now hanging out on the inside. Unless they're in completely different locations at this point. But both of these equations are totally valid and you can still get the exact same graph out of it. Okay, home stretch. Now, let's just write some stuff. Okay, so a cubic, and then again, at any point in time throughout this video, just pause, try, go back, redo problems if you got something wrong. This is just meant as practice. Okay, so I know that this thing is a cubic. So I'm just going to start getting it ready. So this is y equals, I am going to leave a spot in yellow that I've been using yellow the whole time for my a value. X, leave a little bit of space. This is where my h goes. Up there, that's a cubic. And then my k value. Now I'm just going to slide stuff in. Okay, it is shifted 2 units left. 2 units left. That is this guy right there. 4 units down. 4 units down. That's minus 4. Last thing. Vertically compressed by a half. That's my a value. There's my equation. So just kind of set up the bones of what you're trying to do. Keep track of the right, left, up, down business, and then what your a value does. All right, So absolute value. Okay, so I'm going to set up an absolute value. So I have y equals, leave space for my a, absolute value, x, whatever my h value is, goes right there, and then whatever my k. I'm just going to start plugging stuff in. Okay, it is vertically reflected. Oh, that's part of a. Vertically reflected means that's negative. Vertically stretched, that's still part of a by 3. So this is actually a negative 3. Right 2, okay, remember it's opposite of what we think. And then up 7 plus 7. Okay, square root function. Oh, square root. And it is a function. This isn't the plus or minus business. So this is y is equal to, spot for my a value, the thing that makes it what it is. There's my square root, x, my h value goes there, and then my k values at the end. All right, let's start putting stuff in. It's vertically compressed by a third. That's an a value, 1/3. Then it is shifted left 2. Remember, that's the opposite of what you think. And then up 5. Up 5. There you go. I really hope this helps you.